Welcome back, everybody. In this video tutorial, I'm going to talk about inverse functions. Basically, a function is where you put in an input and then it generates an output. And the concept behind inverse functions is, what if you take the output and reverse the whole process to see what was the input that was put in the first place? That's the whole idea behind inverse functions, is you're taking the output and reversing the process to generate the input. The inverse function is basically a function that undoes another function. And here's a set of guidelines that I wrote here in order to solve for inverse functions. First of all, you're going to replace every y with f of x or g of x or whatever it is you're given to make the process a little easier. So you're going to take this f of x and replace it with y. That's what the first step is talking about. And then you're going to replace every x with y and then every y with x. And then you're going to solve for y. And then when you do, you replace y with f inverse of x. And then it's good to verify to see if you found the inverse by taking the inverse that you found and plugging it into the original equation. And if you get x, you'll know that you've found the inverse. So let's go ahead and begin with our example here. I'm going to leave this here for reference. So the first step says to replace y with f of x to make the process a little easier. So instead of f of x, I'm just going to write y is equal to root x minus 3. Then it says to replace every x with y and every y with x. We only have one y here and one x here, so we're just gonna swap them. So x is equal to root y minus 3. And then we're gonna solve for y. If you square both sides, on the left you're gonna end up with x squared. And under the radical, you're going to end up with, you're going to end up with root y minus 3, all of it squared. On the left is just going to be x squared. And then if you square a radical, that's just going to get rid of the radical. And then you're left with y minus 3. And then if we add 3 on both sides, that's just going to give us x squared plus 3. And you're going to end up with y, which is what we wanted from step 3. Now in step 4, it says to replace y with the inverse notation to say that we have found the inverse, that this is the inverse. So we're going to go ahead and verify. We're going to take the inverse and plug it into the original equation that we started with, which was f of x is equal to root x minus 3. So let's go ahead and do that. We're going to get root x squared plus 3 minus 3 all under the radical. We can get rid of the parentheses. X squared plus 3 minus 3. Plus 3 and minus 3 is just going to give us 0, and then we're going to end up with root x squared. And the root is going to get rid of the square, so we're just going to end up with x. And we can say that we found the function, the inverse of the original function. This is a good method to do after finding the inverse, just to see that you're on the right track. Because sometimes you're also asked to find the inverse, and then sometimes you're given a value here. So if your inverse is wrong, then your value is going to be wrong. The number you're going to end up with is going to be wrong too. So let's look at another example. So you're given f of x is equal to 3x minus 2. So let's look at the guideline. It says to replace y with every f of x. So we're going to take y and replace it with f of x, 3x minus 2. And then we're going to replace every x with y and every y with x. So x is equal to 3y minus 2. And then we're going to go ahead and solve for y. If we add 2 on both sides, we're going to get x plus 2 is equal to 3y. Then if we go ahead and divide each term by 3, that's just going to get rid of the 3 coefficient in front of the y. And then we're going to end up with x over 3 plus 2/3 is equal to y. And that's basically 1/3 x plus 2/3. And that's all equal to y. Let's go ahead and verify that. Let's not forget to replace f inverse of x with y. So let's take this function, put it in here. We're going to get 3 times 1/3 x plus 2/3 minus 2. If we use the distributive property here, 3 times 1/3 x, that's just going to give us 1x, which is just x. And then 3 times 2/3, that's going to give us 6 over 3. Yeah, that's just going to give us 6 over 3, and that's 2, so plus 2. And then we have negative 2 hanging out here. And then plus 2 and negative 2, that's just 0, and then we're just left with x. So that's it for this video. I'm going to do another a slightly harder example in the next video. Please go ahead and subscribe and go ahead and like this video. This is going to help the channel grow more. If you have any questions or concerns, please go ahead and leave a comment in the comment section below. And we'll see you in the next video.